No.
She was sitting right there when I told her.
I hate people like that.
Your club is so big, though. Don't you have like 2 separate meetings? Like one for. Didn't she
We used to do it miscellaneous and livestock would separate.
Oh my
That was
gosh.
mainly for like our demonstrations though, because we have like
That's
20
a lot.
demonstrations.
We like barely make it. Like we only had 5 kids.
We're not as big as we were. At one point we had like 7 members.
I remember that.
We have like. Oh,
I couldn't imagine trying to be president and say, everybody shut up.
My first year was hard because I didn't really talk loud. This year I'm just like, people were talking over me and I just sat there and I'm like, started talking once. Like, can you talk louder? I'm like, I'll wait till they're done.
Yeah.
Right.
I just started, shut up.
We had a gavel.
Well, no one shows up to the meetings.
So I would hit that thing.
No, I just started yelling, shut up.
No one really shows up to meetings.
Really? See, ours was like you
But
had to.
we have an attendance and
Yeah.
a community service you have to meet.
Yeah.
I'm in the process of finding out who didn't do that. Because if they didn't, they don't get their pass unless they sign up for the book.
Right.
Mhm.
I'm glad it's not my first.
It's after then you come back and
Just
it's
do like
like
open classes.
I always wanted to do open class, but my cat aren't nice enough because Grandpa just like throws in whatever he wants. I did breed my little Hereford heifer to another Hereford. Do you know who David is? He's Mexican up on the hill. No. Oh, well, he is Hereford. I don't know what his last name is.
I mean, we have a small one, right?
Yeah, I decided we're gonna see how it turns out. We'll see.
That's what I'm doing.
Has been out.
Just want to start breeding. Because we don't have guys quality kids. Traveling to get mine.
Wait, the person used to breed nice goats, didn't she?
There's some guys up north, up toward Napoleon, Bowling Green area that have some pretty decent dogs.
Goats.
Yeah.
Kaylee's trying to find a buck. She's got a doe, but she don't got nothing to breed it to. She's gonna talk to her.
All right then, folks. Good morning, and it's about a minute to 11, so let's get started here. First off, what did people do for Labor Day? Barbecue, travel,
Work.
Just sort of almost all that coming right there. I'm guessing people will be at the fair next week, that is, or the week after.
Week after.
Week after, okay. Mackenzie, can we talk after class about some of the setup stuff that I was thinking? Who here has an agribusiness t-shirt? Okay, what I'm going to do is I'm going to ask the bookstore people if they have some, and I'm hoping, or again, I'm asking, you don't have to. But if you want to, you can buy the shirt, especially the ones who are in agribusiness, and then, if we meet up there, then people can see that, hey, it's not just me. There's 5 or 6 people who actually are in the program, or at least as representatives. So that would be nice, I guess. Okay. Other than that, everything is good as far as our schedule is concerned. We will be discussing the homework, and then we move on to chapter 3. We will try and wrap it up next Monday. I do apologize for the slight confusion that Hannah pointed out last Thursday that, of course, Monday's class, there was no class on Monday, so the homework is technically due today, not on Monday as I stated. Okay, I need 2 volunteers to fill, 3 volunteers to fill this, and this columns.
I'll do the last one.
The real price. Okay, so I need, let's start with the indices. So price or the burger index. So Mackenzie can do that. Okay, so you can do the price one, and I'm looking for a burger index. Madison wants to do that. Okay, okay, we have 2 volunteers. Go for it. So Mackenzie's doing the price one, right? Go ahead. could be tricky, so I do apologize for that.
Yeah.
Okay, yeah, that's fine. It's all right, we can erase it after.
I got the same number, just.
Did it already delete it?
Yes.
Okay.
Can I just type it in?
If you want, that's fine too. But I mean, I do apologize. I asked some people, but it's
Technology.
yeah, but it's weird because if you go to like, I know that a lot of professors don't prefer not to use it, but you know the regular boards with the projectors on top. When you write there, it actually gets saved to the PowerPoint. So that's what I was used to. Of course, the C106 where the technology is kind of funky, the pen doesn't work that well. But I miss C103. That's where most of those classes used to happen. So, but anyway, this class maybe Zoom room or we broadcast to other people from future semesters. So I guess it's good practice. And the people assure me that they will fix this, where I can directly write here and it saves. So. Okay, good. So the whole point is that as you can see, since 2012, with the base here, prices below it, it's always going to be the correct price over the base price. So that's just one method. Okay. In the exam, just a quick pointer. Of course, you have a table like this, but then I may ask you for the interpretation as well. So I hope people are clear as to when you have something like 0.9, that implies that in 2011, the prices were 10% lower compared to 2012. Okay, so it's just a difference between 0.9 and 1. It's 0.1, and that's the difference. And over here, you can see it's 0.12. So in 2013, the prices are 0.12 higher, or 12% higher. So will everybody be at the fair then, or so Shelby will be here, Landon's going to be.
Oh yeah, I'll be here.
Okay, so the class will go on then, folks. So again, please make sure that you watch the video. And I'm only guessing it's only going to be an issue on Wednesday, right? Or will it be on Monday as well?
Might be going on Wednesday or Monday.
Monday.
I gotta see it.
Okay.
See what
Fine.
it's like.
Real price is 4. What did others have?
What? Did I do that one?
That's what I had. Couple
I
here
have
and
a
there.
couple different.
So when you were putting in the numbers, did that automatically round off, or
Yes.
I
so that's because exactly 4 is but I'm guessing if I highlight this, could have rounded out, but I don't know. Anyway, so it should not be exactly 4 for all of them. Okay, so anybody has different point, 4 point something, 4.00. Okay, that seems reasonable. And wait.
I don't know why I did that.
All you have to do, what is the formula? What is the formula that we're using? You have the price index, okay, and then you have the nominal price, and then all you do is just simply divide. Okay, so let me just assure you that we're not doing something that has not been done. So nominal value over price index. It's the real value. So I apologize if it's all like super close to that value, but hey. Questions about this? Okay, if we're happy with it, let's just turn in the homework so that I can grade you. That's pretty much it. You. Okay, let's talk about chapter 3. We started this discussion about utility. Today we want to do something a little more technical, a little more in terms of where this chapter is going and in terms of what the theory actually says. Again, I started talking about what is known as utility, or things or items or goods that satisfy a person's needs. Okay? Chapter 3 is so important. I not only hold it very dear to my heart in terms of thinking about my life, but my whole research focuses on behavioral economics, and this right here is the foundation of all that, okay? The way I live my life is I maximize my utility, okay? If you were to enter my house and walk through, all you'll see is a TV and a Blu-ray player and like nothing. It's a 2-bedroom house, 2 bedrooms, and like a living room, and nothing else is in there. So when somebody else walks in, they're like, whoa, what's wrong with this guy? He's like, there's no furniture, there's like a table and like a chair, and that's it. And the question then becomes, why would somebody choose to live like that? Okay? And a lot of that has to do with something that we're going to understand, that I as a consumer have a certain type of behavior. I choose to spend money on, a good TV so that I can watch Netflix when I have the time, and save the rest so that I can travel. Whereas some other person would feel, hey, I want to make my home look more homely, so I want to invest some of that travel money, perhaps on furniture, okay? People are people, they have all differences. We want to try and understand how people come to those conclusions, okay? How do people decide what combination of goods should we buy so that we are all as happy as possible, okay? Now, I'm guessing people are taking some micro classes here, okay? So if you have already taken something like this, you will see similarity, although we will try and motivate this discussion more towards food as we move along. But this is pretty much an economic perspective. So I really hope to give you something that you can hang on to for the rest of your life. Okay? We looked at some of this, and we talked about Angel's Law right towards the end of the previous chapter. Who remembers what the idea behind Angel's Law was?
Incomes increase, percent of income spent on food decline.
Right. Yeah, obviously that's what I wrote, but intuitively, as long as you understand that, what's that trying to say is that as your income grows, the percentage of that total income that you spend on food is going to decline, because that makes sense. You are more richer, you are going to dedicate more of that towards, furniture or, going to the bar, et cetera, et cetera. So that's the whole idea of Angel's Law. And again, this has been empirically proven with tons of data. You can look at your own income trajectory. Although you're at the point where you're starting out in your careers, compare your spending on food now versus 10 years later. Okay, now this slide, I was unsure that I wanted to put it. It does get a little political, but I let it in there because, it was said so long ago, and a lot of people still live by this. The budget should be balanced. The treasury should be refilled. Public debt should be reduced. The arrogance of officialdom should be tempered and controlled. And the assistance to foreign lands should be curtailed, lest Rome become bankrupt. Okay, so this code, of course, comes from the Roman Empire. Now, who has taken a history class here? Okay, so if you remember your history, the Roman Empire was one of the biggest empires in the ancient world. Okay, a lot of those things, they still exist. I used to live in Rome, Italy, and the Colosseum is still there, and you still see a lot of things from that time very much exist. But this code is directly a sort of a comment on how people should be living their lives. Okay, notice the first line: the budget should be balanced, the treasury should be refilled, public debt should be reduced. Okay, so the reason this slide is here is because it's trying to motivate this idea of how do you satisfy your needs in a meaningful way, so that you're not, going on a credit card debt all the time just so that you can be yourself, you can make yourself happy. Again, there are exceptions, of course. Many people are forced into credit card debt because, they are trying to satisfy basic needs like, food and clothing. But the comment here is generally trying to sort of get to this idea of we always want to live within our means. Okay, let's talk about then the first technical aspect, that is a utility function. Okay, so let me just go ahead and last time the box that was just there was trying to capture what utility would look like. Okay, now of course you have to start thinking of numbers. There's no way to tell whether if Landon has utility of 3 and Madison has utility of 2, what does that mean? Okay, so we need a ground of a common ground through which we can assess how happy people are. Okay, now I do want to say that utility, if you were to talk to like a psychologist, they would have problems with the definition that we have here. Okay, because to them, you cannot really measure happiness in a quantitative way. But we as economists and a lot of companies out there, especially who sell products, they want to think of it in these terms. Okay, so a utility is some function. Okay, some function of goods. Okay. Now, when I talk of a function, I actually mean a mathematical function. Now, we're not going to get mathematical at all in this class. I have learned my lesson. We're going to be as basic as possible. Okay. But just in the general interest, who here has done some algebra or is familiar with basic algebra? Okay. Now again, I don't mean to sound condescending in any way at all. I respect everybody's knowledge, definitely, but it just has been my experience when I write stuff like 2x minus x, this equals. So when I just say 2x minus x, it's just x, okay? And we were not even going to do this in this class, okay? We typically read that to stuff like 33,000, 43,000, so on. But if you want, just from now on further, try and get like a basic algebra book so that you can revise these concepts, because you may sort of need them as we go down the road. Not in this class necessarily, but perhaps down the road. Okay. All right. That aside, so utility is a function of goods. Okay. So I'm going to define two goods. I'm going to say good one is, let's say, pizza slices. And good two, I'm going to say, what do you guys like? Coke.
Yeah.
And what this is trying to describe is a particular situation on any afternoon, perhaps even on Monday when you were celebrating Labor Day. You're having a lunch, you're going to have a certain number of pizza slices and perhaps a can or two of Coke. And some combination of that is going to determine your contentment or your happiness level or your satisfaction at a certain point during that lunch. Okay? And that's what this utility tries to capture. We are interested in what this number is going to be. Okay, now, did everybody write this down? Okay, because I'm going to erase it. Okay, so I said that utility is a function of goods. So all I'm saying is that in the example that we just looked at, utility equals pizza slices times, this is a multiplied sign, you have 3 slices of pizza and a can of Coke. That gives you a certain utility level. Okay, so hypothetically, so as an example, U equals 3, which is this right here, 3 slices, times 1 can. What is this equal to? 3. Okay, so your utility is, of course, now an obvious question that you may think of is, wait, but why this? Who decides what this function is? Pizza times Coke. Why can't it be pizza plus Coke? It could actually be pizza plus Coke. However, usually when we're thinking of utility, especially from an economic perspective, and there's a lot of empirical studies that you can learn at a high level of economics if you're interested, that utility is best described when we are taking a combination and multiplying them. This is a Cobb-Douglas functional form of utility, which back in the day, 2 guys named Cobb and Douglas spent hours looking at consumer data. So like guys going to Walmart, going to restaurants, and then coming up with this idea that utility usually is best described when you're multiplying the consumption. Okay? When you actually add them, it creates a separate utility function which has a corner solution problem which you're literally not going to worry about. Okay? Because that's just a high level of fun you don't have to think about. Utility, best explained when you're multiplying the goods that you're consuming. Okay? Now it's entirely possible. Pizza slices and Coke, what else could we have for the same lunch during the same sitting? Is there any other good that you guys like?
Fries.
Okay. Yeah, towards the end, as a dessert, absolutely. So in that case, utility could be slices times cans times okay. And then perhaps you have 2 of them. So what is our utility now? 6. Questions about this? Okay, so what I want to do is I want to take you back to this right here, which is exactly the same thing, okay? They're using hamburgers. You already had the pizza. Instead of Coke, they have hamburgers, okay? Quantity, let's say 2 hamburgers times 2 slices of pizza gives you total utility. And you can multiply further if you have more items, okay? This approach assumes that utility is cardinally measurable in the same sense that a ruler measures distance. Okay, now again, the word cardinal, you're just thinking of incremental size. 2 minus 1, 3 minus 1, 4 minus 1. Okay. We learned that consumers only need to rank alternative combinations of bundles of goods. Okay, so this point here, I can't write this, but this point here is important. Please make sure you keep a note of this. Okay. What do I mean by this point? Let's take a quick example again. Suppose you had bundle 1, so a particular combination, the example that we just looked at, where U1, or the first combination, is 3 slices of pizza, 2 cans, and then 2 brownies. This, of course, equals 12. Okay, but maybe instead of going this route, you could have gone for 2 slices, 1 can, and 6 brownies. What is the number that we get? 12. Okay, so what this is trying to say is that between these 2 choices, you're getting the same level of happiness. So if you were a rational human being, you will pick either of these. Okay? You can choose to have 3 slices, 2 cans, and 2 brownies, or you can just have 2 slices, 1 can, and then 6 brownies. It's giving you an equal level of satisfaction. If we were in a scenario where suppose this was 3, then this would become like 18. And then it makes sense for you to choose this, not this, because you get a higher level of utility. Of course, there's this idea of how can I afford this stuff, which we'll get to in just a second. Okay, but that's what the second point is trying to make. Okay. Ranking total utility. So you have, let's say, a bundle A, quantity of hamburgers, quantity of pizza. 2.5 times 10 is 25. 3.0 times 7 is 21. 4.0 times 6.25 is 25. Rank A and C over B, indifferent between A and C. So you can choose option A or option C. It's up to you because you get the same level of utility. However, it does not make sense for you to go for option B because you're objectively less happy. Okay. All right. Marginal utility, an extremely important concept. Is the change in utility derived from an increase in consumption of a particular good? Okay? And we will look at what that formula is trying to tell us. First thing that you want to make a note of is this symbol here. This is going to be sort of a thing for the foreseeable future. This symbol means an increase or change. And the context is important. You cannot just directly say an increase. The most precise way to think about this would be a change, but I'm going to still put increase as well because many times it literally just implies an increase. So when I say delta utility divided by delta hamburgers, then I mean how much does utility change as I eat 1 more hamburger? But I'll explain that a bit more. Okay, just keep this in mind. The pronunciation is delta. You can call it a triangle, but the official terminology would be a delta. By the way, these slides are up on Blackboard, so if you want, feel free to print them. Okay, I'm going to close this for a second. Let's go back to. Okay, so we're trying to understand what marginal utility is. Okay, we just looked at the example where we were having pizzas and cans of Coke. Okay, and now we're trying to determine at what point do we reach our maximum happiness level. Okay, so let's start with just one good, that is pizza. Just one consumption of food product. Okay, usually I'm not a super big pizza guy. But you know, if it's like a really good pizza from Papa John's, first slice is okay, second slice I'm feeling good, third slice great. Fourth is my limit. Like if it's a medium-sized pizza, I am content by the time I'm fourth. Somebody goes, okay, just finish the other two slices as well. I would perhaps squeeze in the fifth one. By the sixth one, I'll throw up. Okay, so the analogy I'm trying to make here is that you're eating. At some point, you're like, I am the most happy right now, and after that your utility starts to drop. Okay, so that's exactly what marginal utility is trying to capture. Okay, as you eat every pizza slice, how much does your utility change? Okay, let's look at a very quick example. So of course I have some formal definition type slides, but they don't do a good job working through the steps. Okay, so let's go through the steps. Suppose you have on this column the slices, and then here I'm going to put fillet. Okay, we're just thinking of you're consuming one thing for your lunch, and that's pizza. You have the first slice, you have the second slice, you have the fourth slice, Again, before you laugh at me, oh, this guy's so weak. We need this 4 slices. If you have a higher capacity, more power to you. Okay, this is my example. Okay, so at the first slice, let's say my utility is 2. I eat one more, I feel a bit happier. Say 4, 5, and then at the 4th slice, I'm at my happiest. Let's say it's 6, and then the 5th slide, my utility is actually 4, and then if it's 6, then I'm literally down to 1. Okay. I get no pleasure out of eating the last slice. So what marginal utility is trying to do is trying to capture this movement. Okay, we actually want some numbers as you go through the speed. So I'm going to go ahead and create a new column that is NU. Now, if you recall, then marginal utility is change in utility divided by change in hamburgers. Okay? So when I talk about change, I mean the utility immediately after minus my previous utility divided by the slices I consumed immediately after minus the ones before. Okay? I went from 1 to 2, and then my utility went from 4 to 2. The first point, the first column here is always going to be blank. Okay, there's nothing going to be there because you have nothing to compare it from. At the first step, you're like, hey, I just started out. I don't know what the taste of the second slice feels like. So you have no base comparison. So your first one here is always going to be where you start out from. There's no marginal utility for the first. This is not 0. In the example, please not put 0. There's no meaning if you put a 0 here. There's no marginal utility at the first slice. However, at the second slice, who can tell me what this number is going to be? And let's work through it. How do we determine what the marginal utility is when you have 2 slices of pizza. Remember, it's change in utility divided by change in the pizza slices that you have. So it is going to be the change in utility. So the first thing, the way you want to approach it, when we talk about change in utility, okay, so it's let's say change in U over change in P, which is pizza. The way you find it is U next or new minus U old. You went from slice 1 to 2, so the next utility is 4, and then the old utility was 2. That's the change. 4 minus 2. And then divided by, you went from 1 to 2, so it is P next minus P old. So then this number, so what do I put for U next? 4, and then the old one, which is 2, and then divided by 2 minus, and I believe this equals, this is 2. Questions about this? Very important. All right, what I'm going to do is I'm going to go ahead, I'm going to erase it. Fine, this we just found out was 2. How do we then go to the next one? We just found out at slice 2. Now we go to slice 3. How do we get that? 5 minus 4 divided by 3 minus 2, which I believe if you look at it is just 1. The next one is going to be 6 minus 5 divided by 4 minus 3. Also going to be 1. What happens then after that? Negative. So it's going to be 4 minus 6, which equals negative 2. Okay, and then of course divided still by 1, so it's going to be negative 2. And then we go from 4 to 1, which is in fact negative 3 divided by 1, which is also negative 3. What this column is trying to show you is how you were like, okay, my marginal utility just started going up, it reached a maximum point. Internally, as a human being, you always want to stop at 1. Okay? Most people, like in a rational setting, sometimes you do go into the negative 2 setting. Who can give me an example why that would happen? I mean, you know for a fact that you're getting negative utility at that point by having that extra slice. But why do we, in real life, often end up doing it anyway? Yes.
You're at grandma's house and she's forcing food in you.
That is so again, humorous response, but that is mostly correct. And in a more like an economic setting, you bought food, right? And now you're not gonna throw it away because hey, I spent like dollars on it, so you're gonna force it. The best example where this happens and where restaurants obviously want you to do this is at a buffet. You're like, $10, I'm gonna eat everything, even though after a while, based on all our capacities, we're going to hit this negative 2, and quite often that's the best place where you see we dip down into negative 2. That's the idea there. Okay, now I do want to quickly point out something. Here you looked at an example where the pizzas, the differences, change in the slice was always 1. 1 to 2, 2 to 3. In the exam, it's possible we go from like 3 to 5. So please make sure that you always do 5 minus 3 that case, so 4 minus 3 based on the example. Okay, good. Questions? Again, we'll do a sample problem in just a second so that just, I hope I don't have the same numbers, but I think I have some. Okay. So here is how you can graph it. Now in the exam, I want to assure you, I'm not going to ask you to make any graphs. That just takes time. But you still need to be aware of the general idea, and it's possible that I ask you to label some stuff. But here you're consuming hamburgers, or in the example that we were looking at, pizzas. Notice how your total utility is going up and up. Marginal utility is the column that we just drew. Notice how as you have more hamburgers per unit of time, you get to a point where your marginal utility pretty much vanishes. And this is a separate example, but that's the idea. So in life, if you want to just conduct a social experiment on yourself, try and find where your zero is for different types of food you eat, or different types of clothes you wear, et cetera, et cetera. Okay? You can have this application for anything. For travel, where you take like a 8 or 9 day trip, and then you're debating, should I have gone for the 9th day as well? Because you're so exhausted from traveling everywhere that 9 days, spend the money on the hotel, and now I don't feel like going anywhere. So all of that ties back into this. Okay? It's one of the key pillars of behavioral economics. It's very, very interesting to me. I often go to Universal in Orlando, Florida. Who's been to Florida? Okay. Who has been to Universal? Okay, so again, now people think I'm crazy, but I'm a big fan. When I was going there, there's only 1 or 2 things I'm really interested in. The whole park, the Island of Adventure, and what's the name of the other one? There are 2 or 3 parks there. They're all really good, and I have been there like 3 times in the past year. And I'm going there so often now that I'm thinking, okay, this time when I go in October, I'm going to buy an annual pass because that's more efficient. And I told my friend, I was in Ohio State on Monday, and I said, dude, what's wrong with you? You're like a grown man who's 29 years old. It does not make sense for you to go to like a kid's park every 3 or 4 months. And it all comes back down to this. If my marginal utility is nowhere near 0, and if that's something that I enjoy doing, I should have no problem. Now, you cannot extrapolate this to dangerous behavior like doing drugs and stuff, okay? No, because there's actually research on this in terms of behavioral economics, because, again, I know that the opioid crisis is a big thing in Ohio, but one of the things that people have examined is, obviously, drugs are addictive, but we're trying to understand it from a human perspective. How can we organically make sure that people don't consume drugs? And a lot of that has come down to this debate where, how do we make sure that, obviously, even if you were getting some marginal utility from consuming drugs, by the time you get to 0, it may be too late for you. So how do we alter this idea that we start showing a consumer or a user of drugs that you're hitting marginal utility negative way before that? Okay. So different context, but a lot of that comes back to this. Okay. Also, please do not do drugs, like ever. Okay. All right. Marginal utility decreases as more of a good is consumed over a given time period. We looked at that graph, the table that I showed you. And which brings us to the question, and oh good, we have different numbers here. So let's go ahead and fill this in. Again, what I'll do is I'm going to go ahead and write the formula down for you so that you don't have to refer to it. NU equals change in utility of the change of this life system. Write this down, and I will, maybe you can see numbers so I don't have to close that. Mackenzie has questions?
No.
Okay, you already did it?
Yeah.
Good. Also, again, this is a small class. If you ever feel the need that, hey, you're going too fast, you gotta let me know, okay? It's not just the money you're spending, always think of it life, and we're gonna talk about budget constraints, not just in money, but time. The most important resource we have as human beings is not money, it's time. And 1 hour and 15 minutes, anything that you're not clear with, you gotta stop me and ask. There's plenty, and don't worry about, oh, we won't finish the syllabus. It's just like 2 chapters, I'm gonna give you an updated syllabus. We don't have to do it. Okay, so I'm guessing everybody had this for the first one. The next one is 3, 3.
2, 1,
-1,
-4, -3.
Simple enough. Okay, now, like I said, this is just all one incremental changes. In the exam, please do not forget about any jumps. Indifference curves. Okay? I'm gonna explain and define what that means. A cardinal measurement of utility is both unreasonable and unnecessary. We can instead use an ordinal measurement of utility, which means all we need to know is that one bundle is preferred over another. Okay? I don't want to use the word problem, but a difficulty in this kind of assessment is that you're only thinking of pizzas. And right at the top, I showed you that if you're having a typical lunch, you're consuming a bundle of goods, okay? There may be that odd day where you're like, all right, I'm just gonna shove pizza down my throat, and that's my lunch, but typical consumption is always going to be a combination of stuff, okay? Modern consumption theory is based upon the notion of iso-utility curves, where iso is Greek for equal, okay? You don't have to know the meaning of the word iso. The consumer is assumed to be indifferent among different combinations of goods along an iso-utility curve, okay? Now, this is something that I have been debating, but the way I understood utility was in a very graphical or very visual way. Here's how I will try and explain it to you, okay? Let me take you back to this graph right here, okay? Don't think of the second graph, think of this one. Notice you will see total utility on this axis, and then hamburgers on this axis. As you eat more hamburgers, your utility goes up and then it peaks at one point. The shape of this utility curve is like this. And for a normal human being where you're consuming a certain standard type of good, like hamburgers, this is what our utilities are going to look like with slight differences. Okay? And iso utility is nothing but a different variation of the same graph. Okay? So, you just have hamburgers here. Suppose you not only were eating hamburgers, but you were also eating pizzas. So 2 goods for your particular lunch. Okay? When I draw a graph like this, let's say, so pay attention to the floor for a second. You have on this axis, this is the x-axis, and then suppose this side is like the y-axis, or whichever way you want to draw it. So it's the L that you see. That's right over there on the board. Okay? When you insert another good, let's say pizzas, you have to think of 2 now. How do we draw the same graph using 2 goods? And that's where the challenge is. And hence you need those indifference curves. Okay? So again, stay with me. I know this is slightly tricky, but I'm not going to ask you an exam question. I'm just trying to make you understand the shape of that iso-utility curve. We just looked at and L. So let's say X and Y. The moment you have a second good, however, you will have two goods and then a third axis right here. A three-dimensional axis, if you will. Okay, so what you're trying to do then is you have pizzas on that axis and then hamburgers on this axis, and then your total utility is being captured by this axis. So do you see the three-dimensionality of it all? Because then the room is like a box in which you're making like a curve. And the curve still has the same shape. I'm standing at the corner. Think of like a bulge or a mound rise from this corner. It hits a peak, and then it descends because you're having too many pizzas or hamburgers. There's a happy maximum somewhere in the middle of this room in open space where the combination of pizzas and slices is best for you. Okay? When we get to this point, this isoutility curve is nothing but a slice. When you take a sword and slice it, you get like a shape, which is this shape. Now, it's difficult for me to sort of show you where this may come from. What I will try and do in next class is I'll try and draw like a 3D image, and then we slice it, and then we get this shape right here. You will notice that on this graph, there is no utility. You have two goods. On the x-axis, you have hamburgers, and then, of course, you have tacos on the other axis. So what that is showing is those slices on the floor, but not the utility ones. Because, you know, on paper, you can't show a 3-dimension. It's like a paper, so it has to be 2 dimensions. So this is what this tries to show. Now, I want to assure you that none of this 3D stuff is going to be in the exam. All I'm trying to do is I'm trying to motivate where this shape actually comes from. Because sometimes the obvious questions are the most annoying in the sense that I feel like professors just don't explain to undergrads and people who are just starting this out where the shape is coming from. They just automatically assume that, hey, it's like a sort of a U. And then if somebody asks, hey, but why not the other way? They'll give you some reason, but not the real reason. The real reason of the shape is you have a mound, and then you're slicing it like a contour to capture this idea of pizzas and tacos, or hamburgers and pizzas on this axis. Okay? That is an indifference curve. Okay? Now the word indifference, the interpretation of that is this idea that, let's say you were at point Q, 5 tacos, 2 hamburgers. If you go from Q to M, your utility remains the same. You have 2 more tacos and 1 less hamburger, and you still are on the same indifference curve, which gives you the same utility level. Okay? Indifference. You're indifferent between 2 different consumption bundles because you get the same utility level. Okay? Quick pause for questions. Please ask away. Mackenzie has a question.
What if you go from like Q to N?
You go from like Q to N?
Yeah.
That is a jump, and your utility will increase. And I was getting to that right after this. Okay? So the idea on this, any point on this curve, you have the same utility. The moment you go from this to this, you have high utility because you're consuming more, and you have 4 hamburgers and somewhere between 5 and 6 tacos. So your utility is high. From 200 to, let's say, 700. However, between N and P, the utility is the same because you're any point in this curve is the same utility level. A shift to the right is an increase. If there was a curve to the left, that would mean a decrease. Okay. The 2 indifference curves here can be thought of as providing 200 and 700 utils of utility. I have never liked this word utils, this word usually is for an undergrad level terminology. I feel like a lot of economists don't like this word, but we're gonna still let it be here. All this 207, when I say util, just think of it your happiness level or your contentment level. That's all that unification does. Okay. One would normally expect a number of additional isoutility when difference curves. So, you could have infinitely more you can think of. Here you have just two examples where we're picking 700 versus 200. The slope of an indifference curve is known as the marginal rate of substitution. Okay. Now, I don't want to make anything technical here. Who knows the simple definition of a slope? A slope?
Changing the line or changing it.
Exactly. So obviously that's the technical idea, but when you're just thinking of slope, just think of literally like a slope going down the slope. Okay. Is you saw that indifference curve, it is sort of going down a slope. All we're trying to do is that we're trying to capture how fast you're going to go down that slope, and that's the marginal rate of substitution. The marginal rate of substitution of hamburgers for tacos is given by change in tacos divided by change in hamburgers. How many tacos do you want to give up for more additional hamburgers so that you have the same utility level? Okay, so without even looking at this, let's just on a broad understanding. You were having 3 hamburgers and 2 pizzas or 2 tacos, and you were getting a certain utility level. All I'm asking you to do is switch that combination around so that you are still getting the same utility level. A lot of times in the real world, you may have to do that because, hey, guess what? You're standing in front of McDonald's and they're like, you know what, sir, we ran out of hamburgers. Can you switch to something else? That is literally a real world example of that. You then switch to something that gives you an equivalent level of contentment or utility. Okay, but we want to make this a little more formal, so we are going to look at some numbers here because that's just easier that way. So, I'm going to put pizzas in this axis. And so we have some indifference curve. Okay. Suppose originally, when you were going out for lunch, at the beginning, you were at this point where you had 3 slices of pizzas and 2 cans of Coke. Now, before I even move further, I want to make sure that people understand how to label graphs. Does everybody get how we are labeling graphs, how we identify a point on a graph? I'd be happy to go over it. Please ask away. Okay, so x-axis, y-axis, 2 points. always the, so let's say if I ask you to label 4, 3, go 4 here, go 3 here, wherever the two meet. That's step 1. Okay? 3, 2. So right over here. Okay. So this was your first point. This is where you are right now. Okay. Now suppose I say go from 3 to 2, but then in return have 3.5 cans, 3.5 cans of Coke. Okay. Let's see here. Color red. You were at 3 and 2. You changed your bundle to 2 and 3.5. Obviously, now 3.5 cans of Coke makes no sense, but for this example. Okay. All I'm trying to capture is the MRS. Okay. Or the movement from this point to this point. The marginal rate of substitution. The MRS then is the change in Coke over the change in pizzas. Who can calculate this value? The change in Coke. I gave you 2 points. Went from 3 to 2 and went from 2 to 3.5. Who can calculate what the marginal rate of substitution is? The change in Coke is Coke that you were consuming and the Coke that you're consuming now. Change in pizzas is pizzas that you were consuming and the pizzas that you're consuming now. Obvious answer. Okay, so let's just start with the basics. Let's look at pizzas first. You were having 3 slices of pizzas. Now you're having 2. Okay. 2 minus 3. Okay, so since it's going to be a denominator, let me. 2 minus 3. What about Coke? What were we consuming and what are we doing now? We were consuming 2, and how much are we consuming now? 2.5. So, consuming 2, 2.5.
What if the second 2 on the denominator be flipped? Because you went from 3 to 2.
Okay. So the idea is right here. Remember, you always go from old to the new. So the new is always in the front. New minus old. You were here, you went here. It's going to be 2 minus 3.
53 minus
3.5 is the new one. 2 is the old one for Coke. So keep that in mind. Here's how it's just better. Let me write the final answer, then I'm going to just write the formula down for the breakup so that you have that in front of you too. Who can calculate what this value is? 1.5 equal to questions. The interpretation. What is this formula telling you? Okay. number of cans of Coke you're willing to give up for one additional pizza. Okay, now, let me just erase, if everybody's written this down. Okay, so in the exam, for questions in general, there's only going to be two goods. Okay, some good here, some good over here. All right, so the MRS for any two goods, okay, let's call them X and Y for simplicity. To find it, all you have to do is Y new, which is the new value, minus Y old, which is the old value, divided by X minus X old. And you don't have to write like in a fancy way like this. Just make sure it's internally clear in your head. Old is always going to be stuff that you borrow from. So that's where you started out from. U is always going to be in the front. Okay. MR is between points M and Q. So notice we're doing the exact same thing. Obviously the numbers are different because separate question. Q and then M. So the change in tacos, the difference. Okay. And then of course you have the change in hamburgers. Right? Exact same idea. They of course have different values. Whether it's we got -1. Please make sure you start this. Who has, I see at least one book there, which looks like a reasonable addition. It's probably the, by the way, the Pearson people are just being total hard asses for no reason. Bookstore is super annoyed. The dean is annoyed with Pearson people too, because apparently a lot of professors and students are reading on their books. So there is a book available, the latest edition in the bookstore, but I mean, you don't have to pay. Okay. This means the consumer is willing to give up 2 tacos in exchange for an additional hamburger. All right. Along the same indifference curve, the decrease in taco consumption from point M to point Q times the accompanying increase in the NU of tacos must be identical to the increase in consumption of hamburgers from point M to point Q times the accompanying decrease in MU of hamburgers. Okay. Now again, the way you want to visualize this is notice that when you were eating tacos or hamburgers for each of those goods, okay, we were looking at like pizzas and Cokes. For a certain type of good, when you're eating it, you're getting a certain utility, okay? We are trying to capture that as you change a good, you go from, let's say, 2 tacos to 1 taco or 2 pizzas to 1 pizza, your utility changes. And how do we identify that change? That's called marginal utility, okay? For 2 certain goods, change in tacos times the marginal utility of tacos equals the change in hamburgers times the marginal utility of hamburgers. Now what I want to do is I'm going to write a more generic formula so that you can apply this to any particular case. So let's do this. Change in Y, some good, times the marginal utility of Y equals change in X times marginal utility of X. Alternatively, you can write the same formula this way. So quick basic algebra question is, how did we go from this to this? For bonus points. Rawr. We go from this to this. Basic idea. Okay, so just
Isn't it like cross multiplication?
exactly. So it's cross multiplication. So this times this equals this times this. You just cross multiply them. Okay? There's no tricks here. It's literally basic algebra. But I need to know that you get this though. Okay? Okay, let's move on to the budget. And again, we have about 5 minutes or so left. I will quickly introduce it, and then we can move on. Let's worry about the equation there in just a second. Let's talk about it here. What does the word budget mean? Okay, people have incomes, people have money. I'm guessing everybody's working here somewhere. And when you first start out, the first proper income that I was earning was in a coffee shop. I was way back in 2011. 2012, I beg your pardon. And at that time, you're really thinking of, I was making what, $1,200 a month, which is good enough for rent, and you can dedicate some of that to food, and then the others you ask parents for other stuff. That budget constraint, those times, is a lot more representative of the budget that we're going to look at here, because we're just strictly thinking in terms of the food or rent, etc., etc. Here, the way you think of a budget constraint is the stuff that you're consuming multiplied by the amount that you're actually paying for that stuff. Okay, and then obviously that budget, whatever that total is, has to be the amount of money you actually have. Okay, so if you earn $1,200. We have, of course, you can remove rent or whatever, and then you have about $500 left for food. There's only so many pizzas and hamburgers you can buy with that much money. You can decide what the combination is based on the utility we looked at, and then you spend all that money or less of it. Cannot be more. Okay. Although there has been a lot of debate amongst economists where these models don't account for credit card debt, where technically you don't have the money, but you spend more of it. But we are not going to worry about that, okay? Just don't think of you taking any loans or anything. Think of the money that you actually have in your pocket, and then you're deciding how much you're going to spend, okay? Let's talk about what this actually looks like. The budget constraint. Price of hamburgers times the quantity of hamburgers. Okay, so give me a price for hamburgers. How much does it cost? $4.50. Sure. Okay, so I'm going to put P of H as $4.50. Suppose in a month you have about 10. So quantity of H, you have about 10 hamburgers. Price of a taco, $2.50. What's the, wait, what do I go for tacos? Taco Bell, right? What's the going rate there for a regular $2.50 something? Price of taco, $2.50. Okay, and suppose in a month you have about 20 tacos. Probably probably not good for your heart, but hey, they're good. Okay. Can somebody tell me, based on these numbers, how much money would I need in total if I have to satisfy these needs? What is the total amount of money I would need to satisfy this combination of prices and quantities? Can see the correct answer.
I think it's 95.
95 is correct. We will work that throughout. Just give yourself 2 more minutes, make sure you get that. The amount of hamburgers you're consuming times the amount you're going to pay for each of them. 4.5 times 10 plus the amount of tacos you're having times the price of each taco. 2.5 times 20. 4.5 times 10 is 45. And then 2.5 times 20 is 50. Which of course equals 95. Without even worrying about the numbers, any budget constraint, whatever you're consuming, you're paying something for it. Add all that payment up, you need at least that much or more than that. All there to it. Okay? I'm going to go ahead and stop right there. Let's come back on